Hello, class.
Hello.
Okay, so welcome to BMED 3400. It's our Intro to Biomechanics class. So first and foremost, as far as textbooks, because I know this is the first week, I know you guys are trying to get those out of the way. Look for Engineering Mechanics, the Dynamics, the 5th edition. I don't really have a preference as far as which textbook you get. Most of the text is like you can find it in the PDF file, and like there are a couple of times when I'll give it to you through PDF file with Dr. Tane's lecture notes already on it. So going ahead, are there any questions real quick?
What about the course objectives?
Okay, so first and foremost, we are going to go over the stress and strain distributions in bone and simple structures under tension, compression, torsion, and bending. So we're working a lot with bone. We'll go over the mechanical properties of biological tissues, and then we'll also go over the motions of particles in rigid bodies. So those are the objectives. As far as materials, this class is going to be based on your statics and dynamics classes that you've taken previously. Okay, so I have a problem for y'all. Is anyone brave enough to try to solve a problem on the first day?
We'll do it.
Alright, sweet. I'll go ahead and write this problem. Alright, here you go. So I've made this problem for you. And what I want you to do, so this is the problem. We've got a human femur and it's mounted on a torsion testing machine. And the femur is going to be subjected to a torsional loading until it fractures at the section AA. And then the applied torque or moment versus the total angle of the twist is shown in the graph. And then I want you to assume that the bone is approximated as a uniform cylindrical tube with a cross section as shown. And let me draw you the cross section. So there you go, you can begin this problem. What I want you to do first is derive a formula that describes the shear strain, and I want you to do it from the given information. So go ahead and do that, and then afterwards I want you to tell me what at the moment of the fracture is the shear strain of the inner and the outer surfaces of the bone. So yeah.
Alright, so to solve this, we'll use the equation phi is equal to length over radius times tension. So we have our phi is equal to 20 degrees based on this graph, which is equal to 0.349 radians. Our length is equal to 0.37 meters because we convert this to meters. So then we have the constant equal to r over L times phi. So then we have 0.349 from this over 0.37 meters times radius, which will get us 0.94 radius as this constant. So now to find the next part, to find the inner one, we do 0.94 times radius 1, which equals 0.94 times 0.007 meters, which we get because we're told radius 1 is 7 millimeters, so converted to meters it's 0.007. So that gets us 0.0066. And then for the outer, we will do 0.94 times radius naught, which equals 0.94 times 0.013 meters, based on this converted to meters again, which gets us 0.012.
Okay, very good, Zavni. That's absolutely correct. So this is just going to give you an example of what we're going to be doing all semester long in this class. So it's just an introductory course to the principles of mechanics as they apply to the biological systems. And so we'll cover like the basic concepts and approaches for solving deformation and dynamics problems relevant to biomedical applications. So we're going to have a huge emphasis on problem solving. So I'm going to have you proposing a problem and then solving your own problem. So that's going to be a lot of what your homework, your tests, and your projects are going to be over. So thank you.